Would you break this dang thing, or would it break you? Let's get technical. Would you break this dang thing, or would it break you? Let's get technical. What? Out of all the fun sci-fi weapons in the Men in Blackiverse, the noisy cricket might be the most famous. Absurdly small and absurdly powerful for its size, this tiny gun is known for its crazy strong recoil. Now, we know almost nothing else about this weapon aside from its recoil, but I think that if we can put some numbers to its oomph, we can learn a lot more about it than some dudes in suits would tell us, because no matter where the Men in Black got this weapon, physics works the same everywhere in the universe. First, I can't see anything. First, what is recoil? Well, recoil is the term that we use for a weapon's backwards momentum. It's mass multiplied by its velocity. And that backwards momentum is a consequence of the conservation of momentum, a principle that states that in a closed system with no energy going in or out, no matter if objects collide or not, the total momentum before and after whatever happens is the same. Say, for example, you were an MIB agent watching a bug-piloted UFO smash into the old World's Fair Unisphere. Your classic textbook example. If the UFO hits this sphere and then sticks to it and they both travel on together, you'd expect that this whole mass would be moving at a slower velocity than the UFO was initially traveling at, because the combined mass is so much larger. And indeed, when we do calculations for different objects like this is exactly what we find. The arrows of momentum before and after are exactly the same. That's conservation. The conservation of momentum is at work everywhere. Say you had some kind of rocket car with off-limit buttons. Another classic example. The backwards momentum or recoil this rocket car will get will be the mass of the rocket exhaust multiplied by the velocity of that rocket exhaust. Now, exhaust as gas is not very heavy, and so that's why rockets have to throw it back out of something at ridiculous speeds with basically controlled explosions. Whatever the noisy cricket is firing, it's not going to be that heavy either, because you can hold the whole gun in your hand. And so this simple equation can give us an idea of exactly how fast it has to fire a projectile in order to move someone like Will Smith. And spoiler alert, it's gonna be way faster than that thing. Wow, don't touch the button. Don't touch the button. To calculate the ridiculousness that is the noisy cricket, we need to know a few variables first. Our equation is very simple, but we still need to know the mass of Agent J in the first Men in Black film. We need to know the velocity that he is thrown backwards at, and we need to estimate the mass of whatever the noisy cricket is firing. If we do that, we can solve for the velocity of that projectile, and hopefully that value will let us determine what the noisy cricket would actually do and what it would do to you. Oh, I did break it. Men in Black was right. If the noisy cricket really is so small, it would be downright scary. I felt like I said that. Did I say that already? If a weapon has a lot of recoil because of the conservation of momentum, that means it's either firing something relatively light at an enormous velocity like rockets do with fuel particles, or it is firing something much heavier at a relatively slower speed. As another example of the interchangeability here, the Saturn V rocket, one of the largest rockets ever, was thrown up out of Earth's gravity well by throwing rocket exhaust downwards at a blistering 2.5 kilometers per second. Now, you could get the same recoil or momentum change by, and follow me here on this one,
throwing a blue whale straight down at Mach 1.7 every 2 seconds.
Whale! 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 Ah, beautiful. I'm bringing up blue whales and exhaust and rocket cars because I hope by now you have a good idea that for a tiny gun to throw a grown man across a room, it simply must be firing something at an unheard of velocity. So let's get technical. Looking to the Men in Black films and the prop replicas of the noisy cricket that fans have built over the years, the diameter of this barrel cannot be more than a few millimeters wide, maybe 3 to 4. So tiny. To fit inside the barrel then, whatever the noisy cricket is firing has to be less than this diameter, maybe 1 to 2 millimeters? Small. And if the projectile is made out of some kind of earthly material, maybe a spherical shape, how about steel? Then the total mass ejected from the gun would be just 4 milligrams. Finally, Will Smith is 82 kilograms, and I think now you can see that for just 4 milligrams to launch something that is over 20 million times more massive, the velocity on display here must be ridiculous. But just how ridiculous it has to be will depend very much on the amount of Fresh Prince of Bel-Air time that Will gets. Nope, you can't make me forget it. I'll never forget it. To complete our equation, we need Will Smith's recoil velocity, and for that we're gonna do what we always do in movie velocity situations. We are going to need the frames of the movie and the frames per second of that movie to get some time value, and then we're going to need to look into the movie to get some known distance of something to get a distance value, and from that, distance over time velocity. This clip from Men in Black 1 is playing at 30 frames per second, and for Will Smith's final toss from the noisy cricket in this scene, I counted a total of 23 frames. To me, it looks like he is traveling and thrown backwards about a half of a full car length, the average in America that we can look up. And if we have these two values, then we can get an average velocity to plug into our conservation of momentum equation. I'm leaving all these variables in our equation here because you can mess around with how far you think Will Smith is actually traveling in that scene, what the projectile is made out of and therefore its actual mass, how many frames you count him moving for, but the slowest that I calculate the projectile for the noisy cricket traveling is at over 7,000 kilometers per second. The slowest, and at its fastest, it could be traveling at relativistic speeds. I'm talking like 60,000 kilometers per second, 100 million miles per hour, 20% the speed of light. Not only is this faster than anything ever fired on Earth, this is faster than our galaxy moves. What? There is still the question of what firing the noisy cricket would actually do.
Yeah, and what it would do to you. I'm an alien.
Whoa, you were not supposed to see that. Speeds of thousands of kilometers per second and above fall into the regime of
Hypervelocity.
and we've actually tested what hypervelocity impacts would do to stuff to help protect the people who might actually meet aliens one day. By definition, anything that is orbiting the Earth is going pretty dang fast in order to stay in orbit, and that also applies to pieces of space debris and space junk, like little flecks of paint or little pieces of metal, and those would be incredibly dangerous at orbital speeds if, say, you were an astronaut up there. That is why NASA has actually built giant gas-powered guns to fire stuff at objects to see what they will do at hypervelocity. Here is an image of one of those test impacts, firing a little piece of something at 17,000 miles per hour. That looks pretty dangerous. Here is video footage of a test of a little metal sphere hitting sand at Mach 100. Still looks really dangerous. If the noisy cricket is firing anything at thousands of times more than these test velocities, it's not totally implausible to assume that when it did fire something, when it hit it, it would do a lot of damage. Wow, that hurt. How much would it hurt though? If we forget about the velocity for a second and just look at the total momentum imparted to Will Smith when he is thrown by the noisy cricket, we get a value that doesn't really mean very much unless you compare it to something else. So let's compare it to something else. This is about the momentum that a linebacker in the NFL running at full speed has. And we know that NFL players, when they hit you, can throw you a decent distance and absolutely rock you. So now imagine all this momentum concentrated in just your wrists, shoulders, and elbows. If you walk away from firing this thing with just a broken wrist, I think you would be lucky. I'll never forget this pain. But despite the relativistic firing speeds, despite the momentum, despite the broken bones it would probably give you, I still don't think the noisy cricket would ever actually throw you backwards. Like good physicists, when we started asking this question, we more or less assumed that Will Smith is a perfect Will Smith sphere, and any force acting on that sphere would act equally and simultaneously. But of course, we know that humans are not perfect spheres to be launched by something. What Hollywood has either ignored or forgotten for years is that humans are what we call squishy bendy, and even immense recoil will quickly dissipate itself in the bending of our bodies, our arms, and our limbs, and a lot of it will just transfer into the ground. In fact, I'd wager there may not be any movie situations where someone is firing an accurate weapon where they'd either knock someone through a plate glass window or be thrown backwards themselves. The noisy cricket is extremely impressive and probably very dangerous, but its depiction of recoil is a little Men in Whack.
Nope! Nope, I'm gonna remember these puns forever!
So, why is the Men in Black's noisy cricket so dang impressive? Well, because of its depiction in the movies, it just has to be firing projectiles faster than any bullet on Earth, faster than any human-made object, and faster than some galaxies move. The noisy cricket might not throw you through the air in real life, but it would definitely break stuff, and probably break you. Because science. There is one small problem with whatever the noisy cricket is firing, and it's that if you're firing something that fast, it's gonna immediately vaporize itself in the air. Even if it was a metal sphere, a steel sphere, for example, firing at 100 million miles per hour, it would immediately vaporize itself, and it would be more just like relativistic steel iron ions flying through the air. And would that do the same amount of damage? How far would that plasma of steel actually go? Probably not as far, probably not do the same kind of damage, but that's where we can kind of make the hand wavy part where it's an alien material that's resistant to Will Smith shots. Thank you so much for watching, Sammy. If you want more of me or you want to suggest ideas for future episodes, you can follow me and Because Science at these social media handles here. And don't forget our first expansion show, Because Space Expansion. It's like the expansion. It has a number of episodes now live. You're going to want to check them out with Dr. Moo, who is absolutely lovely and very, very smart. And she's just great. And if you like it too, let us know in the comments. Thanks.